all. Welcome back to this third session for the day. The speaker for the third session is Dr. Shrikant Joshi, sir. Sir is currently working as a professor in Department of Electronics and Telecommunication Engineering and holding a position as an assistant professor at Vishwakarma Institute of Information Technology, Pune. He has received his PhD in Electrical Engineering with specialization in Signal Processing and Communication from Indian Institute of Technology, Bombay, and bachelor's and master's degree in engineering with specialization in electronics engineering from Shivaji University, Kolhapur. His main specialization research interest is audio and speech signal processing. Currently, Sir is working in the area of automatic speech recognition application towards computer assisted language learning. Sir has published 7 papers in the international journals and conferences. Also, he has received a travel grant of €650 from International Speech Communication Association to present research paper at Interspeech 2015 at Dresden, Germany. So, on behalf of JSPM's Rajarshi Shahu College of Engineering and Department of ENTC, I, Shraddha Bingardeve, welcome you, sir.
Yes, good afternoon. Thank you for introduction. Just I will share my screen and then I will start.
Yes, sir.
Okay, is it visible?
Yes, sir.
Okay, so shall I start now?
Yes, sir. Please, sir.
Okay, so good afternoon to all of you. So today I'm going to deliver a talk on automatic speech recognition in computer assisted language learning. So actually the theme of this particular STTP, which is artificial intelligence and application towards biomedical engineering and all. Okay, so it is little bit off the actually the theme, but again I will introduce you what are the different applications of speech signal and in medical field or biomedical engineering we can say, and then I will switch to my topic, which is computer assisted language learning. So that will be a good transition we can say, and to the actual speech application to the medical science that will first go through that, and then I will start. So if you see this particular screen, so I have just mentioned, so I am not going in detail about what are the different applications of speech processing in medical field or biomedical especially, but I just noted over here two very important areas. So those are interested to work in this particular area along with the background or along with the knowledge of speech signal and its processing. Definitely one can continue research and further studies in this particular area. So the first application that I mentioned, so long back it is already well developed, established. It is a binaural hearing aid. So basically it is an acoustic signal received from both ear and it feed to the auditory center in a brain, which manages the adequately filtered speech from sound and suppresses the background noise. In this way, speech intelligibility. So those are hearing impaired person. So this is a very good device, can be useful for basically for help them in hearing. Okay, so another important thing that recently there are so many papers which are published in this particular area, that is detection of Parkinson disease. Okay, so just I was 2 years back also I was thinking in this particular area of working, but somehow I could not continue in that area. But definitely this is very good area. This is detection of Parkinson disease. That is, Parkinson disease is neurologically disorder contained Parkinson disease, epilepsy and Alzheimer. Parkinson disease create cognitive and state of mind disturbance. So this is very important, and this is basically captured with the help of speech signal. So studies shows that the sign of Parkinson disease can be detected through speech. So this is very important thing. Okay, and very important research paper, that is Sannes et al. That is presented their work in 2011, a methodology that enable the establishment of the 10 best features to identify patients with sign of Parkinson disease. The range of symptoms present in the speech includes reduced loudness, increased vocal tremor, and breathiness in the breathiness like signal. Okay, so this is we can say that one can continue his speech knowledge or the knowledge that he has in speech signal processing area in medical field also. Some of the papers that I have just mentioned, I will just mention here that research on Parkinson disease. So there are few important paper that just I have mentioned over here. That is one paper that is Annas et al. That I just earlier mentioned. That is IEEE 2011. This paper is published, and the title of this paper is Novel Speech Signal Processing Algorithms for High Accuracy Classification of Parkinson Disease. Second one is Kagler in 2010, that is automatic recognition of Parkinson disease from sustained phonation, that is actually a speech test using ANN and adaptive neurofuzzy classifier. The third paper, automatic evaluation of speech rhythm instability. So speech rhythm instability, that is very important keyword over here, and acceleration in dysarthrias associated with basal ganglia dysfunction. So that is Rouse et al. That is, they presented this paper in this particular area. So there are so many papers, and recently, if you see this paper, that is a comprehensive study of speech signal processing algorithms for Parkinson disease classification and its use. And one more very important paper, that is Braga, is presented in elsewhere on acoustic analysis of speech in Parkinson disease. So I think there are various journal papers, conference paper you will find in this particular area. So we can again connect this particular speech signal processing and its application towards definitely in biomedical or medical science to help human beings to improve the life of human being. Okay, so that's what I want to mention here. And the another thing is binaural hearing aid and all. So speech processing for a physical and sensory disability. So this is long back, it is already established, and so many devices which are already there for hearing impaired persons. Okay, so this is also one of the very important area. With the help of our speech processing understanding, speech processing knowledge, we can apply that particular knowledge in this particular area. Okay, so I think with this summary, we can say that definitely, even though we are saying that speech signal, how we can use for medical field or in biomedical applications. So these are the two important areas that I have mentioned over here. So now let's continue with our discussion or this presentation towards the automatic speech processing or automatic speech recognition towards computer assisted language learning. Okay, so here just I want to mention that just I want to understand how many of you are aware of just this speech processing area. So just according to that, I will tune my presentation. So just can you raise your hand so that I can see over here? Those have studied speech or they have a little bit background, so that I can make this presentation very interactive. Otherwise, it will happen that if you don't know anything about this particular area, it is very difficult to cope up other things. Okay, so just raise your hand, so I will get to know. So just raise your hands. Those have worked or little bit background of speech signal processing. Participants, can you hear me? So just raise your hand so I can identify. So I will get to know. So okay. So just quickly just raise your hand. So I will not waste time, and we can study this particular topic so you can understand it better. So one. Okay. So quickly, can participant raise your hands? That will be easy for me. Instead of just looking into the chat box, just raise your hands. Okay, I think not many are conversant with this particular area. Okay, so can you see this slide?
Yes, sir.
Okay, so let's start with this particular session, like this particular application, that is computer assisted language learning. So what exactly the computer assisted language learning? So before explaining this, just I will give you the brief idea about this particular area. So it will be easy for you to understand the findings of what we have done. Okay, so this particular area, so consider that your mother tongue or the first language is, so let's say Marathi or Gujarati or Kannada. Okay, and you want to learn a second language. Okay, what you can do, you take a help from a teacher, right? And he teach you the second language. Okay, so nowadays online, so many things which are available, you can learn the things, right? So is it possible to assess your performance using computer? That is the question. Or if the good teachers or appropriate teacher which is not available at a particular place, so what we can do? Is it possible to use a computer system or computer system to assist a human being to learn a second language? So not only in Indian languages, suppose if you want to learn Japanese, if you want to learn German, or if you want to learn some other language, okay, but you know only one or two languages in India and in Indian scenario we can say, and you want to learn different languages. So can computer assist? So that is the basic thing. And so wherever there are errors that you are doing in pronunciation of a particular phoneme or particular syllable or particular segment of that sound, computer should able to assist you in making you familiar with that particular sound, and you can easily pronounce that particular sound. And he can give the evaluation, or he can give you the rating that what is the degree, or what is the, at what level you achieve that proficiency in that particular language. Okay, so this is basically the application. Okay, this is just a brief idea about computer assisted language learning. Okay, so this is acoustic. So for that, what we require is to understand the speech processing or the knowledge of that speech. Okay, so here just I have mentioned here, those have not understood, those have not studied this in detail. So we have some vocal cords over here in the throat. Okay, so there are different parts of our mouth. Okay, so lips, jaw, nasal, tongue, oral cavity, nasal cavity. So many things are which are present, and the voice which is produced. So lung is a main source of basically the energy source. Okay, and this vocal cords. So we know that from when we study the language, we have studied there are two important things in the language that we have studied. One is the phones, which are consonants and vowel. Okay, so how the consonants are produced? Consonants are produced without any vibration of this vocal cord, and the vowel sounds or voicing which is produced because of the vibration of this vocal cord. Okay, and because of this, actually the tongue, the air pressure which is passed through this mouth. Okay, through this mouth. So from lung to mouth, this is a journey of this particular air pressure and the different sounds which are produced. When we record the signal using the microphone, what we get is electrical signal. Okay, and that in that electrical signal, we further analyze and process that particular data. Now, if you model this based on what you can say, how does the electrical signal which is generated over there, or how the sound which is generated, acoustic signal which is generated, so vibration of the airs, how it is generated. So we can model this based on a random source. So whatever is the unvoiced sound, it is modeled using a random source, and the vowel sound like e, u, a, o, like this, these are the sounds which are modeled using this periodic pulse train. And now this pitch of this particular vowel sound, which depends person to person. Okay, but there is certain range in human male and female speakers. Okay, in male the pitch is very low, and in female the pitch is very high. Okay, so either we can connect this vowel part or a consonant part, and then the filter which is applied over here, and filter is nothing but this particular system, that is a mouth, oral cavity, nasal cavity, the area, cross section area of this particular these cavities, that decides what type of signal, how the signal which is produced. But definitely one thing is there, that when I say a different person pronounce say a or e, definitely we recognize that particular sound as a. It is not a person specific, that one person pronounce a and other person listen it as a e. Okay, so means there is a certain training which is there in human brain, right? So this training which is very important. So now suppose if computer system, now the systems are very well established, and automatic speech recognizers which are available. Okay, the algorithms which are available, you can easily get some databases are also available, and you can easily build the speech recognizer. But now further thing is how we can apply that, or how we can use that recognizer in our different applications. So that application that I've chosen over here is computer assisted language learning. Okay, so just in the next slide, just I will explain about this, what actually the signal is. So this is the waveform which are captured. So those are not familiar with the speech. So this is the on this particular point, you can find over here that this is the acoustic signal converted into electrical. Okay, so this part which is unvoiced, this part which is unvoiced. Okay, and this part is a vowel. Okay, and if you observe here in blue, this is the pitch, this is the pitch line. So in case of unvoiced part, you will not find over here pitch, because as per our model, the unvoiced part or consonants which are generated by a noise source, and the voicing part which is generated by the pulse train, periodic pulse train. So you'll find here that the vowel part which is somewhat periodic over here. So this is somewhat periodic. Okay, and this is not periodic. So this is a consonant, and other parts are voice or vowels or semi vowels, something like that. Okay, so I will not go in detail about this, but at least you should know how this signal looks like, what exactly the signal is, what are the characteristics. Now you will find here some red dots over here, some red dots over here, and this red dot indicates that this red dots indicates that the energy which is concentrated in this particular band. So this is called as a spectrogram. This is called as a spectrogram. So this is the time axis, and this is frequency axis, and third axis which is the intensity. So what does the spectrogram indicate? It indicate that these red dots indicate the Forman frequencies, or the what is the oral cavity or nasal cavity, the resonances of this cavity. So this cavity is there. So resonances of this cavity are given by these formants. Okay. So you will find that whenever I pronounce some vowel, so a or e, so you will find that so different vowels are there, but these formants are different in different segments. So this is one vowel, this is another vowel, this is third vowel, but the energies are different, right? So formants are different in energy associated with that frequency. Those are formants are different in this case. Means we can define or identify this based on the nature of this formant. So this is very important characteristics, that formants are different. So that's why how we can recognize say a with e, or a with u, or o with u, or long and short like ee or uu, how we can recognize. So these formants or duration is also very important parameter for a speech signal. So these are important characteristics or features we can say, and based on these features we can use a recognizer and to identify. So suppose if I compare this, so if I characterize this particular vowel, and if I compare this with some learner's vowel, so let's say what I can do in case of assessment or evaluation of a particular person's speech. So what I can do, I should have some models associated with the each and every vowel or syllable or word level, and then we can compare these vowels and we find basically the probability. So probability of closeness, or what we can say, it's a correlation we are finding. So how the learner speech which is correlate with the model, okay, and based on that we get some confidence score. So try to understand overall that we have to attain certain level, and to attain a certain level, at what level that we achieved is based on the comparison or the correlation. So let's say 90% you achieve, 70% you achieve, okay, so this is not correct pronunciation, so you have to pronounce like this. So computer, if computer should inform that, so about your mistakes or where you want to improve, okay, so this is the application that we are thinking about, okay. So we continue with this as for the next slide. So the introduction of this is related, as this is the topic which is related to the speech processing, and motivation is this is related to the Indian English, and what we consider here as the target language is English, and the source language is basically Marathi and Gujarati. These two languages that we consider over here, and we use the speech recognizer in finding this errors in pronunciation of specific vowels. So motivation is basically the strong demand of Indian English. If you India in English spoken language training with the limited availability of teachers, vowels are the critical components. Whatever I mentioned over here, consonants and vowel. So vowels are the critical components of segmental error, influencing both accent and intelligibility. And availability of automatic speech recognition technology that can be potentially served to detect mispronunciation automatically. And the challenges with respect to this particular area, which is ASR system needs large amount of label training data for the required accurate acoustic modeling. And here our approach, what is I am going to discuss over here, the approach is combination of the available data effectively as well as knowledge of expected confusions based on native language 11 influence. Okay, so basically this is just an introduction related to what I am going to discuss about this particular area. So here overall what we can say, that input speech is there. Now it's a system, you can say this is a complete block, and you want to evaluate or assess the performance of a particular speaker based on a different level. So what is a sentence level analysis? So if I pronounce a particular sentence, if I utter a particular sentence, what we can say that what about the stress pattern, what about the intonation at sentence level, that can be analyzed. Again, stress and intonation, stress analysis at word level, at the segmental level. So if you go from bottom to top, we can say that the very basic unit is of speech signal, which is a phoneme, and from that we go on top to the like phoneme to syllable, syllable to word, word to phrase, phrase to sentence, sentence to paragraph, like that. Okay, so at what level you want to evaluate the performance, that is important, and the system can give the different scores based on at what level you are interested in evaluation of the system. So now, if just I mentioned about this mispronunciation detection of GIE vowels. So just we consider vowels as an important segment or the important part of the speech, and GIE vowels, that is General Indian English vowels, to provide automatic assessment and feedback in computer assisted language learning. So Indian English, so General Indian English is a, we can say that is a, we defined as a, so Bansal and Harrison, you can get this reference as defined as standard Indian English is a clear, effective, and intelligible English speech without a detectable regional accent. And the commonly accepted phonology is defined by for Indian English with the term that is General Indian English. So here we consider the source language as Gujarati and Marathi, which are a part of Indo-Aryan language, and some languages which are Dravidian language. So these two are the Indo-Aryan language family. And target language is a general Indian English that we consider over here. Okay, so I will go to the language phonologies and expected vowel confusions, proposed system architecture, databases, training and validation, acoustic models and confidence measure, vowel mispronunciation detection experiments, prediction of subjective global pronunciation scores, and conclusion. Okay, so I will go through this. So this is very important slide over here to understand what exactly the language phonologies and reduced vowel space, or how two different languages which differ. Okay, so if you consider the English, there are 11 vowels which are present over here. Now here is this diagram relate to our tongue. Okay, so just understand that tongue which is fixed at the back. So this is the back side. Okay, towards your throat. This is the front side. Okay, and while speaking, what happens is there is a movement of our tongue. There's a movement of our tongue, and based on that, whether our tongue comes front, center, back, or half closed, half open, or open, depending upon that, the vowels, which vowel will get produced is defined over here. Okay, so if you consider that if our tongue is at front and it is closed, so when you pronounce the vowel, that is E, so what happens, your tongue which is coming in front, and when you pronounce say U, your tongue is going back, or O, your tongue goes back. So it's basically a movement of our tongue. So this diagram indicates the movement of our tongue. Okay, so now if you consider the Gujarati, so generally what happens in Marathi and Gujarati in spoken. Okay, so we have, when we write a specific word or the phoneme, what we can say, language script, in that we identify that there are short and long, like E is there, U is there, then A or something like that. A is there, not long A, but in speaking, it is coming in between. Means we are not basically distinct between these two vowels. Okay, and that is the basic problem. So if you consider the example here, that why this errors, where these errors are coming in. Suppose I'm a Marathi speaker or Gujarati speaker, I'm speaking English as a second language. So just if I want to map this, so what happens is here, when I produce a sound, beat and bit. So beat is longer one, and bit is short. Okay, so definitely what happens is acoustically these two are different phonemes. Okay, so it basically, you can identify it based on the form and structure as well as its length, duration. When I say beat and when I say bit, or gate or get, so AA is gate or get. Okay, so depending upon this acoustic, okay, so there are distinct vowel, but we generally tend to, somewhere we try to pronounce it in between, and there are error. Okay, so if I say full and fool, so if you pronounce these two words, actually the meaning is different. Okay, feel. Okay, so the different meaning, but the underlying vowels are different. Okay, so in spoken language, so this is very important over here. So we have just taken up this particular problem. So there are different other evaluation that can be done over here. So this is the problem, that there's a mismatch between the phonology of this vowel reduced space, and that's why there are certain errors. So that these are the groups that are mentioned over here, that this is the group. Okay, and the errors which are occur over here. So we can say that these are the further vowel substitution errors. So bed or bad, caught, coat, so these are the different words. So I will not go in detail about that, but there are two errors, that is the laxed vowels and vowel substitution errors. So this is a similar way we can say about the Marathi language, these groups. And now we are coming to the point that what is the system according to evaluation system would be. So this is the proposed system that we consider over here. Okay, and just I will explain about where that different algorithms like artificial intelligence, that is a title basically. So we can say that nowadays we use different machine learning algorithms. Okay, so what is the role of that machine learning algorithms? Learning algorithms. Machine learning means take a data, okay, model that data and use those model for your purpose. So now here you can say that we have a system, we require some system that should able to evaluate the performance of proficiency of a particular speaker. So what we can do? So for that, what we require? You require some text, right? So some text should be read by text reading by a particular speaker. You can take that as an input, so that is a speech signal which is considered over there, and what level that you want to evaluate. So if I want to evaluate at a phone level, if I want to evaluate at a syllable level, at word level, or at phrase level or sentence level, depending upon that you have to design your system. You have to design your system. So again, so the paragraph which is given for a reading means you know the underlying text. So based on your acoustic signal and the models which are trained models, acoustic models which are trained, we can align and we can segment that data. So segmentation is very important over here. And those segments which are given for uh, mispronunciation or confidence measures. So if you see this, there are different blocks. So first block indicates vowel segment extraction. So if I want to evaluate at a segment level, so this vowel segment should be given over here. If I want to evaluate at a syllable level, the syllable should be provided to the system. If at the word level, you have to segment the word and then you have to provide that to the system. Okay. So second system is phone confidence score. So we have to use some acoustic models which are trained using, let's say, DNN or CNN or HMM. Okay, these trained models, you will get some confidence score. And once you get some confidence score, based on that confidence score, you have to use some classifier to detect whether the pronounced vowel or the syllable or the word which is correct or incorrect. So mispronunciation detection. So what was the reference vowel or reference syllable or reference phone? What is its confidence score? And based on this classifier, it will decide that whether your signal or the speech is correct or the pronunciation is correct or incorrect. So overall we can say that the system will take a data. So overall system will take a data from a person. He will read out a paragraph or what a sentence or a word, whatever required over there. Then we know this paragraph. So text we know. So based on that, we can align, extract the segment and give the segment for finding the score, and then use that score along with the reference. We can use or we can classify whether it is correctly pronounced or mispronounced. So for the validation, this reference vowel will be there. Okay, because to get the score, this reference vowel is further required. Means it is a text is available. So based on that text, we can use. So text transcript plus dictionary. So we can use this text transcript plus dictionary to do the segmentation part, and then we can get the confidence score based on the acoustic models. And these models which are trained using, let's say, DNN, deep learning neural DNN or CNN or different other training models we can prepare, like HMM, GMM, HMM we can prepare. Okay, so problems address are acoustic model training, then the selection of this model, selection of features for mispronunciation detection task, and prediction of global score. So once we get this particular score, so for at a sentence level, suppose if I want to evaluate it at a sentence level, so if I evaluate, let's say, at the phone level, so what will happen? So in a given sentence, there are multiple phones are there. Okay, phonemes are there. So if I can say that if there are at a phone level, if I want to evaluate, on an average there are, let's say, 50 phones in a sentence, and out of that 3 or 4 which are in mispronounced. Okay, so we can say some algorithm that will give you some score that will decide or take that input as an input, and it will decide that whether this is correctly pronounced or mispronounced. Okay, so this is how we can prepare the mispronunciation detection system. Okay, so now very important thing over here is training and testing databases which are required for the evaluation of a system. And here in this work, what we did, we use the different databases and the combination of these databases to get the system in place. Okay, so we use the American TIMIT data that we know all, the TIMIT database, then TI for Hindi database, GI adaptation database, Model I paragraphs database. All these databases, when you consider over here, these are recorded, and annotation is manual, and annotation is done, and all these databases which are prepared. And for the mispronunciation detection task, we prepared different databases like word databases, paragraph databases from Marathi speaker, Gujarati speaker, those having the L1 as Marathi or Gujarati, and then uh, they are learning of a English learners. Okay, so these all these databases that we have prepared, and based on these databases, we train the models. So there are different speakers and material that we used for development of this material. That is the standard English paragraphs like Stella or North Wind, Anderson, and Rainbow. These are the standard paragraphs, and we use this paragraph for as a reading material from the different speaker like Model I and Gujarati I, Marathi I speakers, Indian English speakers. Okay, so this is related to the database, and then somewhat list. So those are interested can go through this. So as I mentioned here, that word data, while preparing this word data, so there are different vowel like E or A or A or A or something like that. So there are different corresponding words that we prepare like beat, gate, or bat, or past, cut, caught. So some list which are prepared, and based on this we recorded this for this data. Okay, then annotation which is done, manual and annotation which are done, confusion matrix which are prepared. So some tokens which are correctly pronounced, some tokens are wrongly pronounced, and we have to use this wrong and correct tokens for development and basically training the systems. Okay, these are the just the evaluate this the paragraph that is used for this particular recordings. So highlighted words which are very important keywords, and those words we isolated, and then the vowels which are extracted, and the vowels which are extracted from that particular word, and the subjective evaluation which is done at that particular vowel level. Then the segmental quality, whether the segment is correctly pronounced or mispronounced, that is also done using the subjective evaluation. And then subjective ratings at segmental quality where vowel substitution, fluency, and speech rate. So further we'll come at the end of this presentation, I will explain about this fluency and speech rate, these parameters for evaluating the pronunciation evaluation. So if you consider the English pronunciation test, TOEFL and all. Okay, so there are let's say many students appearing for the test. So where we can apply this? So if I want to screen, okay, so first screening that whether this English is proper or not. Okay, so let's say there are 1 lakh somewhere odd students appearing for the test. So based on this computer system, we can segregate say around 10,000 or something, depending upon the percentage. We can filter out this particular students, and then at a subjective evaluation that can be performed. So instead of going for a huge subjective evaluation, we can reduce this at different levels. So that's how we can apply this or use this particular task for different application. So distribution of data in a subjective evaluation. So this is basically again for this what we require is even though those paragraphs which are presented or read by different speakers. So at a paragraph level, this segmental quality, fluency, speech rate, that should be evaluated subjectively. Okay, so whenever we apply certain machine learning algorithms, and if we want to validate the system, some subjective rating is important, because subjective rating is very important. So we have to train our system in such a way that our machine should work, or we should able to substitute the human. So its performance should match with the human. That's why the subjective evaluation, which is important. So we again use the different subjective evaluation raters to evaluate these paragraphs, and based on the rating, we basically do the subjective evaluation of model speakers, Marathi IE and Gujarati speakers. So because these are the testing and these are the model speakers. So always you will find that model speakers are rated very high by the subjective raters, whereas some errors which are there. So this is 1 to 5 is a rating scale that we use pronunciation evaluation, and segmental quality lacks in vowels distinction and rating based on the vowel substitution errors. So you will find that almost 4 and 5 rating which is achieved by this model I speaker, whereas there are some problem with the speakers which are new to this particular language. So we can observe that model I speakers are rated very high, and segmental quality as well as fluency. The rating for Gujarati I and Marathi I speakers, which are distributed between 1 to 5, and actually concentration between 1 to 3. And non-native data set has good representation of good, average, and poor speakers. So this is also very important. So if you go to this particular slide and if you check that, so distribution of good and bad tokens. So based on that, basically our system is going to test. So we should have the enough data that should be distributed from say low to high proficiency. Then we use this. The next task is to develop some certain models. So acoustic analysis. So this is a little bit very important. So formant analysis that I mentioned over there. So just I will just go to the. Okay, so I will go to this particular slide, and I will evaluate this. I will mention over here that we evaluated based on this formant. So earlier slide, if you see this in this Pratt that we have seen. Okay, so in this particular slide, we have seen some formants over here. Okay, and the vowels which are classified. So based on the formants, we can easily classify. So not find that whether it is E or E, but at least E and E or E and U or U and O. So this we can classify based on this formant. Okay, so what formant information gives about overall speaking. So that is done based on this formant analysis, and we observe that these formants of the Gujarati speakers or Marathi speakers, which are very much means there is a confusion in this formant at a formant level as well. So if you want to pronounce a particular vowel, let's say if I pronounce E, definitely it should follow certain formant structure over there. Okay, and based on that formant, we can evaluate, or we can classify that particular vowel. So that particular task is also we have done over there, and that way we can cross check that whether really there is a pronunciation errors or not. Okay, so I will go to the next slide, which is acoustic modeling. So this is very important over here, that we have the signal which is present over there, and we have to model that. Okay, so we have to prepare acoustic model. So with the different machine learning algorithm, what we are doing, so in case of medical electronics, or in case of any signal processing task that we are doing, that we are getting some data, we use some certain models. Okay, and those models nowadays, deep learning and neural networks which are used. Okay, and those models, how to prepare those models? To prepare those models, we have to use certain data, we have to extract some features, and the models which are trained on those features, right? So those models which are trained like GMM, HMM, and propose this acoustic model, that are TNN, GMM, HMM, and CNN, convolutional neural network. So these three different categories that we used. Okay, and this combination, how to select a particular model, that is very important over here. Okay, so if your model itself is faulty, definitely you will not get a good score over here. Okay, so here what we use is acoustic model, the 3 model configuration that we select, and to train this model, what we do, actually what we did is we use a different database. So we use say this is an English database, this is a Hindi database, this is an English database that we collected. So paragraph database for the validation purpose, and then we come up with certain model combinations. Okay, And how we come up with this is just I will explain that. So instead of going to this particular slide, so what I will do is what we did, acoustic model configuration and features. So there are different vowels and consonants which are there. Okay, so we are interested basically in vowels. So what we did is, let's say total phoneme in a particular language. So let's say around 48, 46 phone. So we use 11 vowels as it is. Then we selected 6 diphthongs combination, then semi-vowel, nasal, obstruent, silence. These are the broad categories that we use. And we use this 22 class model. So output is 22 class. Okay, output is 22 class. And each class which is trained using 3 state left to right without skip this model, context independent model, and 12 GMM per state. So each state used or trained using the 12 GMM per state. And the feature that we use is 39 dimensional MFCC features plus 13 delta and 13 acceleration coefficient extracted at 25 millisecond window and 10 millisecond offside. So these are the certain details about how we prepare this model. And while preparing this model, once we train this system, so acoustic model trains separately for TIFR and this TIMI data. So this is a Hindi data, this is a TIFR data, and based on that we select different combinations. So how to basically sort out use these models. Okay, so there are different classes which are mentioned. So this is A is American model and bilingual model, which is basically we don't have all 11 classes which are present in this TIFR data. So we borrowed these 3 models from this in English, and just we complete this set of this model. So we call this as a bilingual. So it's English plus Hindi models combination. And then we evaluate the performance on actually the evaluation data set. And we use this some adaptation also over here. So if you see this particular accuracy and also precision recall for Gujarati AI data with GOP measurement. So this are the, if I use the American English model, so what accuracy that I'm getting 46%. So if I adapt this with some Indian data, those models which are get adapted, the accuracy jump to the from 47 to 58, somewhere around 58%. So suppose if I use a bilingual model, somewhere it's accuracy which is lacking over here. But again, if I adapt this with the Indian English data, so straight away the accuracy which is increased somewhere around 61% it reach. So we can say that definitely this bilingual model and adapted version, definitely it will be useful. So if I don't have a data, large amount of the data, so with the help of available data and some adaptation data, I can prepare certain models, and those models I can use for our evaluation. So just coming to the how we train this, the different combinations. So GMM, HMM, that just we discuss about this 22 classes, 3 state left to right, 13 dimensional feature vector and all, and based on the same features which are evaluated over there. But now for the DNN, deep learning neural network, and convolutional neural network, DNN HMM topology, it is 5 hidden layers with 1024 neurons, 66 output corresponding to the each state. So 3 states, so 22 classes, 22 into 3, that is 66 outputs which are trained, and male frequency filter bank energies which are used as a feature vector with 9 consecutive frames and 40 filter banks which are used. So TIMI train set is used to initialize the weights, and then DNN stack RBM pre-training which is used. So these are the bit different training configuration and all. So those are interested can go in detail about this. But these models, so 22 classes which are basically trained using the CNN and DNN topology, and then we use these models for our evaluation purpose. So this deep learning toolbox of the MATLAB which is used, which is developed by Palm et al., that is 2012, and this framework which is developed in Digital Audio Processing Lab, IIT Bombay, and that tool, that framework which is used in this particular experimentation. So we get a DNN. So again, when we train the system, we have to basically evaluate the performance, whether how good these models are. Okay. So DNN and HMM training. So training using only GI data that correspond to 66.3% accuracy. So different configuration for while training that is used or adapted by different researchers. So we use the different configuration, and then finally we come up with which type of configuration which is used, or which reference that we have to adapt for this particular selection of this model that we have considered. So you will find that this particular paper, that is 2013, and this technique that is very well suited for our data, and which gives around 71.5% accuracy, classification accuracy. And for the CNN, again, supervised multilingual training with 73.5% accuracy that we get. We use this particular model for our further studies. So we can, the summary, so GOP, that is, this is a GOP term. So it is goodness of pronunciation. So what score that you are getting for using a particular model, that is a goodness of pronunciation. So from GOP result, both 8 and 4 vowel cases adapted model, that's what I mentioned. Just go back to the earlier slide. So here, so when we say that adapted version, that is around 58% and 60%, 61% accuracy. So though the accuracies which are less, but definitely is a starting point of this particular experimentation. So this shows that actually adaptation works for this particular data. So this is the result, that definitely C2 and C4 models significant improvement as compared to C2, that is the C4 bilingual adapted performs better. And CNN configuration, just now I mentioned that this configuration with supervised multilingual training with re-estimation and supervised multilingual training with CNN, this configuration that are selected for evaluation purpose. So again, coming back to this particular slide, that what we have done. So here basically our speech signal which is coming. So again, I'm explaining because you will get to know what exactly we have done over here. So we trained these GMM HMM models, okay, for segmentation purpose, and this acoustic model. So GMM HMM plus DNN and CNN for evaluation purpose. So starting with this data, so what we have done is we record the data, test utterances are separated, align using GMM HMM using text transcript and dictionary to separate out. Now in this case we require to separate vowels. Sometime if you work on syllable or word or phrase, so you have to separate out that particular segment and give for the evaluation purpose. Okay, now with the DNN HMM, CNN HMM and GMM HMM, these models are trained. So these models are with us, these vowel segments are with us, and now we have to compute the confidence score. So once we compute the confidence score, based on this confidence score, we have to classify. Okay, so we reach up to this point that we train this model, we collect the data, we separate out the data at segment level, that is the vowel segments which are extracted. Now we have to classify. So try to understand this flow. So that's why every time I'm just projecting this slide. So we will come to know that what exactly we have done and at what point we reach up to which point. Okay, so this is what we have done. So now to compute this, basically it is nothing but computation of like probability. Okay, so suppose if I utter certain sound, just I mentioned that when we match a particular signal, means on a feature space, so we are finding the correlation. So amount of matching, so 90% match, 80% match. So based on that we give the score. Okay, so basically we have the observation and we have to find out this observation correspond to which class. So probability of a particular class given observation. So it is basically a conditional probability. Conditional probability. So based on this data driven systems, what we are calculating, either we are calculating the likelihood score or we are calculating the posterior probability. We are calculating the posterior probability. So in most of the cases, calculation of posterior probability is very difficult. So based on Bayes rule, we calculate the likelihood score. And how we are calculating the likelihood score or calculating the posterior probability. So based on that, there are different representations. Okay, so based on this, we get a sort of different features over here. So it is confidence score. It is not giving a single value. We compute different scores. So like average frame posterior estimation or phone confidence, segment posterior probability error, or segment posterior evaluation, or log duration. So all these findings, or all these basically features that we are calculating. So the features at signal level and features at this level, they are different. Don't get confused with that. Okay, so the score feature, okay, and then these are actually signal features. So once we get, so if I calculate a p measure for this, or we can say that it is a measure, okay, score measure, okay, and based on that measure we have to train the classifier and get the mispronunciation detection. So one by one we are going ahead towards detection of mispronunciation. Okay, so what we have is, so from this diagram it is very clear. Okay, so what we can do, we have the proposed models are there. So models which are trained, so any system, so whether it is biomedical system or different other system that you are treating, so there are different models. These models are trained using what? These models are trained using the data. This is your test. Okay, so now in our case what we have vowel segment. We have vowel segment. Okay, this vowel segment is coming over here, and the confidence score computation of each target vowel of the acoustic model. So let's say, suppose if I use, let's say 11 vowels, so I know that this, while testing I don't know what vowel it is. Okay, but for the validation purpose definitely I know this particular vowel is, let's say or this is a, or this is e. Okay, so if I use a model for over here, okay, and if I calculate the score for this, it will give some score. If I use model E, it will give some other score. So best match will be for this vowel is and if I use a model it should give a maximum score. Okay, so like this I will get a set of features will give the maximum score. So theoretically, if I evaluate the score for different 11 vowels using this different configuration, so if I use GMM, I will get some 11 dimension feature vector over here, for example. Okay, so theoretically one value should be 1 or 100% and other value should be 0 theoretically. But what will happen is, as this vowel is not perfect or this model is not 100%, definitely you will get some other scores. So we have to rely on this particular trained models. So we have to find out which model is suitable. Okay, so this confidence score, different confidence score like AP or PC or SP plus some duration, log duration, this can be used, and we can combine this in a logistic regression classifier, and then we take a decision that whether this particular vowel is correctly pronounced or wrongly pronounced. So this is the overall idea about how the system should work. So this is the DNA, this trained models, incoming vowel, get the confidence score, choose some confidence score. So either I have to select all the 11 scores or a subset, or if I want to add this vowel duration or not. Okay, depending upon that. So this, why this vowel duration comes into picture at later stage, because we know that we are intuition is like, suppose if I want to classify, let's say long E versus short E, like E. Okay, so definitely the duration wise there is a certain value, right? So it can easily detect that. So if I add some duration in this particular last stage, definitely I can detect that. I know the vowel is E and the vowel which is with a duration, so there is a one more confidence in detecting this particular class of this particular vowel. Okay, so like this is the overall idea that you will get, that how we proceed to this particular work. Okay, then the selection of the features. So 11 confidence score, as I mentioned earlier, or subset. So we know that, let's say there are groups, like, so E will not get confused with, let's say or U. So just consider a score along with this group, E, or U, or U, or let's say O and O. So within this particular configuration, so in a vowel space, that just again I will. So is it visible now?
Yes, sir.
I will just go to the one slide which is very important to explain this particular fact, this particular case. So instead of getting this 11 different scores, okay, so what I will do, instead of confusing with 9 other vowel scores, what I will do is I will just consider the score with respect to this particular group. with this particular group or this particular group or this group. So this is called as a subset. Okay, this is called as a subset, and that exactly it is. That's what I mentioned over here. Okay, so subset is what? Subset is selection of a specific group. So as I mentioned that these vowels in a given vowel space, this group is very important. So consider only those features. Otherwise, what will happen? 9 other scores if I use, then confusion will increase. So we have to reduce the confusion. So the scores associated with the either for align with E and get the score, and based on that score decide whether it is correctly pronounced or wrongly pronounced. Okay, so that's what we are basically interested in. Okay, so based on this, subset is like this. So mispronunciation detection experiment. So 45 speakers, IE word data cross validation. So this using the CNN. Now we are evaluating which model which is very suitable or good for this evaluation. So we tested 3 models, like let's say GMM HMM topology, then DNN HMM topology, or CNN HMM topology. Okay, and based on that, which one is suitable? So with the CNN acoustic model configuration subset. So this is very important, subset and SP feature. So plus log duration. So duration plus SP as a feature and subset, which gives the lowest weighted average equal error rate. So ER on a precision recall curve. So ER which is around 19%. Okay. And adding the log duration, all acoustic model configuration with PC, that is the phone confidence, and AFP, that is average frame posterior probability or evaluation, this feature vector shows substantial reduction in ER. So equal error rate, we have to reduce that equal error rate. So finally, what we can say that for the different databases and all, we can select a different acoustic models, and which one is suitable for that particular database, we can go with that, and then we can apply or we can use those models for evaluation purpose. So definitely here the CNN HMM with specific features and configuration with log duration or some specific feature set which gives you better results. So this is what we compare the different configuration and we come up with this particular conclusion. Okay, so training on word data, and so this is also very important. So if you don't have sufficient data, so what we can do? So we can use on the word data. So isolated word data collection is very easy. So we can go with that data collection of data, because in speech and also when we go for this such a type of the techniques like data driven system, the database is very important. So a collection of a database and use of that particular database. So it is very easy for word data, and if we use at a paragraph level testing, but definitely how it works, that is also very important. So in isolation we collected this database and we use for the paragraph level evaluation. Further, we can mention here that around 23%. So equal rate is not more than say around 25, so it is around 23. Even though there is a mismatch between this data, still we can say that this data is well sufficient for acoustic modeling. Definitely it is not like 5% or 2% or 10% error rate, but definitely the equal error rate is considerable given a particular data. So if we have the system in place and if you have a data, definitely you can improve upon this and you can get very good results out of it. So similarly, we can say that when we compare 3 systems, that is a performance for the mispronunciation detection task, along with 11 interference knowledge. That is, we know that which configuration subset, which confusing that selection of the feature for mispronunciation detection classified as a training that works better. Okay, so it is found that 11 interference knowledge is useful and shows improvement in EAR. So that's what is a subset. That's what I talked about, that a group, the feature that selection based on the groups, we can easily improve the accuracy. So overall CNN HMM acoustic models with subset SP feature plus log duration shows lowest equal error rate. So this is how we go with this particular task for evaluation of mispronunciation. So further we extend this as a different level, that is a subjective rating. So basically we this is what we got is objective scores, right? So we have to basically match with the subjective ratings and subjective evaluation. That is very, very important. Otherwise, whatever your machine is giving, how we can rely on that. So overall subjective evaluation is also very, very important. So briefly, I will go to that particular part. We use till this, what we got is CNN HMM models, which are very suitable. So we evaluate all those speakers with the help of this CNN HMM configuration, and then we evaluate, compare, or we calculate a correlation between this subjective rating and objective rating. So objective rating given by machine. Okay, now subjective, suppose if I play one paragraph, and if I ask expert to listen to that paragraph and pinpoint, so he will, what he will do, the teacher will do, so what are the mistakes, he can easily grab those mistakes. Okay, and overall rating, he gives the overall rating that somewhere you made this mistake. But machine on the other hand, what it will give, so if you extract each and every segment, machine will give score for each and every segment, and based on that segment, you have to decide in whole paragraph there are, let's say, 100 such vowels are there, different vowels are there, vowel segments are there. Out of that, 10 are wrong. So how we can give the judge the student that whether it is pronunciation is correct or not. So for that, we should have to decide upon this the strategy. So that's why we have to correlate. So same paragraph is listened by a human rater, and he rates something. So let's say 0 to 1 to 5 or 1 to 10 rating. And now this rating for each and every paragraph we have to correlate with the objective score that we get by the machine. And based on this is basically a prediction of segmental qualities. Okay, so for that we do the same thing, and we basically correlate between subjective score and corresponding machine score, that is percentage correct tokens in each paragraph is obtained separately for each error category. So what we have is, we have two categories, that is Laxton vowels and vowel substitution errors, and based on that we ask the subject raters to evaluate based on this. Okay, so earlier what we have seen is one slide that I will mention over here, that now it will be definitely a significant over here while explaining this particular task. Okay, so this is what is subjective rating. Okay, so subjective raters rate each and every paragraph at a quality that is Laxton's confusion and vowel substitution error. So each paragraph we have one rating. Each paragraph we have one rating. Within that paragraph we have so many vowel segments, and those vowel segments are evaluated by machine. So on gross, let's say there are 100 tokens are there. Out of that, let's say some paragraph 10 are erroneous tokens, some are 5 are there, 15 are there, and now we are correlating with this particular rating for each and every paragraph, and then we come up with the segmental correlation. Okay, this is what we have done over here. So if you So if we calculate the percentage correct token in each paragraph and relate with the subjective scores of that particular speaker machine. Okay, so that's what we have done. So first to judge this, so each paragraph is rated by different raters. That is also very important over here. So inter-rater correlation. Okay, so whether the raters are consistent or not, that is also very important. So in research, this is very important fact, that what is the rater given. So rater versus inter-rater, then rater versus manual annotators, because all the tokens are manually annotated. Okay, and rater versus subjective objective score, means machine score. Okay, so even though you will find that there is not that much, so around 45% for the Laxton vowel correlation between inter-rater. So that should be very high basically. But okay, that there means if inter-rater is agreeing upon this, at least our rater and objective should cross this particular limit. Okay, so we can say that what we got is rater versus objective score, which is cross this limit, and definitely we can say that this is a good correlation between rater and objective score. For vowel substitution, the little bit less. This is what we observe, that objective score and rater we got very less. and is NA indicates in Marathi this particular class which is not there, and we are not evaluated for that. Okay, so this is very important. So those are doing research or doing some other further research work. Whenever there is subjective evaluation type of the strategy, this inter-rater correlation or rater manual annotation, all this correlation we have to first find out. Then only we can rely upon our results. Then the next task that we have done is a fluency. Okay, so uh, just you listen to the paragraph of a particular speaker, whether the speaker is fluent or not, how to decide that fluency of the speaker. The fluency of the speaker can be measured in terms of this silence part in this in a paragraph, long pause silence, how, what is the word rate, silence rate. So all these features are mentioned. So we just estimated these features also based on the earlier researcher. They use this particular feature, and we apply the same thing for same evaluation for our data, and then we come up with this fluency of the measurement for this Gujarati as well as Marathi speakers. So just I will summarize this, what exactly happens to this, that fluency based on correlation between this Gujarati I data, so objective score and subjective score. Okay, but for that, what objective score, words per second is the measure for the fluency, which gives the highest correlation. Okay, silence per word, so more silence means inversely proportional. So for Marathi I, definitely it is a good correlation, that is minus 0.7, and because silence per word, if it is more then less is the fluent. Okay, so the feature is silence per word, words per second, and silence per word. So wherever there is a silence per word, you will get a minus value, and speech rate. So the number of words per second, that is evaluated as an objective rating, and then we got this particular value of 0.70 minus 0.75. And reference is what is the papers that we refer. This paper 2007 and 2006 paper that we refer. So based on that, we got this particular value. So reference, and we got a good correlation between this speech rate as well as fluency also. Okay. So to summarize this particular task, that is a preparation from the acoustic model training, different comparison of the different acoustic models, and vowel mispronunciation detection and prediction of global scores. These are the four, we can say, important tasks that are carried out for the evaluation of this particular work. And again, the data collection is a very important task that is carried out. Acoustic characteristics, because without this acoustic characteristics, it is very difficult to extract the features or select or proceed with this particular research work. So we should have this signal and its characteristics, we should know. So web-based interface, definitely subjective rating is very critical, and for that we require some web-based interface to basically evaluate that. And boundary alignment. So when we work on these vowels, so accurately aligning these vowels are very important. Otherwise, your score, you cannot rely on your score. So how you extract? So if you want at the word level, you should extract the word. So when you go for the lower level, that is vowels or phori, like that, your accurate extracting the segment is very important, and that's what we got over here. This is one more thing that we refinement strategies that is used. That is a two-stage approach. So these are the publications that out of this particular, and questions, we will take those questions. I think this is the end of this presentation now. So if you have any questions, so definitely I can say that this was not directly related to this particular theme, you can say, but as a biomedical, but definitely at the start I mentioned this speech signal, when you and all, and this is a scope in that particular area, and you can have medical area. That's what I want to conclude over here. So though it is not this application, that's what I mentioned over here, is not related to this particular topic, but definitely you can further use this speech signal for medical as well as biomedical application. Okay, I think if technician will take those questions, and then I will stop over here.
Good afternoon, sir. Am I audible?
Yes, yes.
Yes. Sir, this is Paithane madam. So always it is a treat to hear you from your side about speech and all that. Your dedication reflects in your session, sir. So I have a few questions.
Okay.
So can I proceed for it, sir?
Yes, yes.
So first question is mismatching detection. For mismatching detection, can we use mixed data for training?
Which
Male,
detection?
female, mixed data.
Definitely, definitely. See, if you have a now, if you consider timid data or say TIFR data, so all genders which are mixed, so male as well as female, all the data which is available. If you are using directly for male data training, and if you are using for male or female for the female, that is well and good. But whether you have that luxury of getting all the data, which is very, very important. Okay, so if you don't have, then proceed with that. So if you have a combined data, and if you are using for a specific male or female, no problem. Your result will be up to certain level. So you cannot increase that, but definitely that will be a benchmark. So we can say that. Okay, and then you have to compare the results based on that benchmark.
Yes, sir. Yes, sir. Thank you, sir.
Any?
So the next question is related to feature.
Okay.
So which type of features that we can use to increase this matching accuracy?
Related to what?
Mispronunciation, for
Yes.
mispronunciation system.
Definitely. Actually, what happens if you're nowadays, what happens is you have a strong or good modeling, right? We have DNN, some tools which are available, convolutional neural network. So we don't have to just bother about that particular technique. So first side is what type of feature that you are giving to that system. Okay, so you can treat as a not like a directly black box, but at least up to certain extent we can say that this is a system that I want to use. Now for this, generally use MFCC as a feature, definitely, or mail filter bank energies before MFCC that we are computing, that also we can use. But for the specific pronunciation evaluation, okay, so your features like what is the form and structure and all, if you explicitly or definitely all these parameters which are get compensated or calculated and given to the due weightage for that in MFCC and all. But for machine learning algorithms like DNN, CNN and all, definitely MABs and MFCCs straight away if you use, you will get good results for this. Your data is very important over here, and data importance means how precisely you collect the data for a given application. So representation of a tokens in a specific class, which is important.
Yes, sir. Thank you, sir.
Is it?
Yes, sir. Yes, sir. Yes, more clear, sir.
Okay. So any?
Is this recognition is we can say dependent on the pitch? So is the results can vary with the pitch?
Directly I cannot say yes or no like answer, but definitely if you have a large amount of the data, definitely averaging effect and like that it will happen. Like suppose when I say like a female speaker is pronouncing the vowel E, for example, okay, and male speaker is pronouncing E, so definitely it is, this is what is a class is high front, means our tongue is touching to the means coming front and it stop in that particular diagram or tongue position. Okay, so when I pronounce E and other person male female speaker pronounce E, definitely our brain recognize it independent of pitch basically. Okay, the space which is there, definitely there is a distinct space, discrete space which is available, and within that space even though there is a little bit change in the formant as well as the change in the pitch. So if the pitch is change means your formants that will move upward. Okay, if pitch increase, because it's a basically resonators. These are the resonances. So if the pitch is more, that is the input signal to the vocal track, and that will get output will be the convolution of that. Okay, so pitch will that formant will get shifted, but not that much. Okay, means E will not pronounce like U or E will not pronounce like A. Definitely there will be some cluster. If you analyze the formant structure of say 10 or 100 speakers of data like male and female, you will find one cluster over there. So just I will share that screen. So I can elaborate it more detail. So in my first slide, so if you use this, okay, so this is a tongue position. So when I pronounce this particular vowel like E, male or female, whatever, you will find a cluster over here. So not exactly this position, but somewhere in this range. Okay, so male, female, somewhere in this particular range. Definitely there will be slight, definitely overlap. I am not saying that there will not be overlap, but that's what is a role of the models and classifier to detect that, to identify the boundary between these two and to detect the class, which class this particular phone correspond to. So like that. So is this answer your question?
Yes, sir. So next question is related to speech therapy, sir. What is current scenario of speech therapy using such type of systems? Means nowadays we are using this type of systems in speech therapy.
Yes, yes, definitely we can use. I have not gone in detail about that, so I will not able to comment on that. But definitely, that's why at the start I mentioned that speech therapy I have not mentioned, but just the hearing impaired and this Parkinson and all this is that I mentioned over here. For speech therapy, definitely we can go with this, and automatically we can the performance can be evaluated, and uh, we can use for this. Definitely there will be research is going on, and papers you will find various papers. So actually I not work in that particular area, but as I mentioned, definitely one can find and these papers, and you will get that once you have the idea about the speech recognition, all this speech processing, this AI or this modeling, acoustic modeling and all, definitely that should be useful in speech therapy applications.
Yes, sir. Thank you, sir. Last question is related to simulator and processing software tools.
Okay.
Can you please suggest the names?
Actually, in speech processing, as such, whatever I know, that's Pratt is there for speech analysis. Then for speech synthesis, Sphinx is there. Then for recognition, Kaldi is there, and HTK, Hidden Markov Model Toolkit is there. These are the main tools which are used in this particular case, these applications, speech community. And recently, even Kaldi is very important. Okay, so Kaldi is worldwide it is used. KALDI, Kaldi speech recognition tool is used.
Yes, yes, sir. Thank you, sir. Thank you very much, sir. With this, we are ending question answer session, sir. So I, Dr. Sakshi Paithane, take this privilege to propose vote of thanks to Dr. Shrikant Joshi, sir, for accepting the invitation. Thank you very much, sir. Thank you very much, sir, for sharing the information related to ASR system. Thank you very much, sir. And definitely in future we will be able to arrange the more and more sessions in this domain, sir.
Okay,
Thank
so
you, sir.
if any questions, you can use my email ID, shrikant.joshi@viit.ac.in. So participant, if you have any questions, you can post those questions, and I will answer those questions. So you can contact me on my email.
Yes, sir. Thank you, sir.
Okay, so shall
Over
I?
to Shraddha.
Yes.
Yes, sir.
Okay. Shall I leave this meeting or? Any other?
Yes, sir. Yes, sir. You can stop your presentation, sir.
Okay.
Thank you very much. Thank you very much to all the participants. Please do join to tomorrow's sessions at 10 a.m. Thank you.
Hello, good afternoon, ma'am.
Yes, sir. Yes, sir.
Uh,
Any instructions to the participant?
yes, sir. Yes, ma'am. Yes, ma'am. Good afternoon, participants. Thank you so much for joining these sessions. Same, we have tomorrow session also at 10 a.m. So I request you all the participants, so please join at 9:45 a.m. tomorrow morning. So we'll meet again tomorrow morning at 9:45. So okay, thank you so much.